Yeah, so all class 7 students, I welcome you all now in this MathSense course that is introduced by Mathemagic, and this course will help you to boost up your annual exams. So this is like especially for your annual exam purpose, okay? So that will boost up your knowledge in and concepts in maths. And what I'll do in the first video here today is to boost up your knowledge from the chapter Exponents and Power. Okay, so what I have planned today, we will take up few questions, and that will be from the easier to harder, and that will boost up our knowledge, and we will quickly revise our knowledge from this topic. Okay, and now I'm just displaying the formulas. You'll find out in this picture there are total 8 formulas, and from this, if you just can write it down somewhere, if you already know it, well done. If you do not know some of them, just quickly note down it somewhere, so that before you start the problems, all the formulas are within your reach, right? So the question number 1 that I've taken up, that is a very simple question. That is minus 125 by 216. It need to be converted into a exponent of our rational number, okay, R number. So how we are going to do this? So first, before I show you how to solve this sum, I want to just know that what is a rational number and how we can define a rational number. So I hope all of you know that rational number should be expressed in the form of P by Q. There are two conditions, okay. The condition number 1, I'm just writing it short, okay. Condition number 1, that P and Q, this must be co-prime. Okay, now let me know, how many of you know what are co-prime number? Co-prime number are those numbers where P and Q will never share any common factors, okay. Like suppose if I say 3 and 10, if I say 7 and 9, if I say 14 and 15, see, none of them are prime numbers. So co-prime may not be prime, both of so, but they do not share any of their factors. Just let me take a small example, okay, so that we can actually build up our concepts in concrete, right? So 14 is not a prime number, it's a composite number. So if I break them, I'll get 2 and 7. Neither 15 is a prime number. If I break them, I'll get 3 and 5. So what I can see that none of them are prime numbers, right? But why they are co-prime? Because if you see their factors, there is nothing in common. 2 and 7 and 3 and 5 all are very different from each other, so they are co-prime, right? I hope it's all clear now. So the condition number 2 now. Okay, so the condition number 2 is this, that this q, that's the denominator q, this q here, it should not be 0. That's the condition number 2. So if any number follows these two conditions, that's a rational number, right? So suppose if I say 10 by 15, is it a rational number? The answer is yes, but it's not expressed properly. So what to do now? So we have to write 10 and 15. So if I just cancel them, so by 5, so 5 2s are 10, 5 3s are 15, and so it gives us 2 by 3. So now this is 2 by 3 is a rational number because 3 is also a non-zero number, right? So it's all clear. So get back to the sum now again. So how to now express this given number as the exponent of a rational number? All right. So let's start the sum. So the solution. All right. So how to do this? First of all, we will see that what are called exponents. If I say a number is 4, so is it an exponent form? No. You have to write 4 as 2 to the power 2. So then it's an exponent form. All right. Now suppose if I say 9 it's not an exponent form, so it should be written as 3 to the power 2. So always remember the exponent number should have a prime number in base, so that it cannot be factorized further. All right. For an example, if I say 16 is a number, I want to write 16 in the exponent form, and someone has written it as 4 square. It's not wrong, but it's not absolutely correct because 4 is a composite number, right? So now we have to write 4 as 2 square, and then there's another square. So as we can see, there are multiple powers now. Both of these two are, you see closely, both of these two are in power, so they are getting multiplied. So 2 to the 4, so it's 2 to the power 4. Now 16 is equals to 2 to the power 4. It's the right answer, right? Means it's expressed properly in an exponent form. I hope it's clear now, right? So now let us come back to the sum once again. So the number was minus 125 by 216. As we all know, 125 is cube of 5 and 216 is the cube of 6. So if I write in the rational number form now, so it's minus 5 by 6 whole to the power 3, and see 6 is a non-zero number, 5 and 6 are co-prime, so it's absolutely a rational number. Okay, it's a negative rational number basically because there's a minus sign before that. So that's it. Alright, so the sum is done. The answer will be minus 5 by 6 whole to the power 3. So with this sum, I just want to highlight another one rule of exponent that says that if the power is an odd number, always remember, okay, if the power is an odd number, this minus sign sustains there. Okay, means for example, if I say minus 2 to the power even power, suppose for an example 4, so minus 2 to the power 4 will give you only 2 to the power 4. Just remember that if the power is an even number, okay, if it's an even number, the minus sign dissolves, okay, it's vanish away, means it's just cross. Alright, so it's simple as that. 2 to the power 4 and 2 to the power 4 will give you 16, so that will be the answer for that particular question. Alright, so is it clear now? I hope it's clear now. Alright, so the first sum is done, and I think it's all clear and it's quite simple. Moving back to the next sum now. Alright, so the next sum that I've taken, that is also quite simple one. So I just want to know the answer of this. If I say this is the question of minus 2, what to do? Minus 2 whole to the power 3, again a third bracket whole to the power minus 2. So what will be the reciprocal of this? Okay, reciprocal of this number. So first let us break this and let's see what is the number itself. Okay, let's see first the formula chart, as I am displaying it once again so that you can recall it quickly, as I know that some of you have not yet copied this, right? So if you see the formula number 1, actually that is the definition of negative exponents. So this reminds you that if anything having suppose if I say 2 to the power minus 3, so anything having a negative power, okay, negative power, so the power basically becomes positive when you reciprocal that. Means the answer of 2 to the power minus 3 can be written as 1 by 2 to the power plus 3. Alright, so the 3 becomes plus. Why? Because the 2 became now 1 by 2, means half. Is it alright? Just remember like this, that if the power is negative, then we reciprocal the base. If the power is negative, we reciprocal the base. Alright, okay, so what we can see here, that the number that is given in the question, that is having a multiple power, right? So if I see properly, it's minus 2 whole to the power 3, and another power was there that was minus 2. So as I've told you, if there are multiple powers, means more than one power, they just simply get product. Is it all clear? I've already told you, and if I show you another one time, you will see this is from formula 6, okay, for 6, okay. Just recall the take a screenshot of that particular formula page, okay, and you can just get to know that. Alright, so now let us go to the next step. So minus 2 whole to the power minus 6 we got, okay, because 3 into minus 2 is minus 6. Is it alright? Now if you see the power is negative, so if I say to make the power positive, what we have to do? We have to reciprocal the base. The base was minus 2, so it's reciprocal now. So now its power is 6. Is it alright? Now as I have told you that if the power is odd number, again check it, the power is an even number, then the minus sign in the base, that just get dissolves, means just a cross. So the next line can be written as just a half whole power 6. Is it alright? Now this is what we have done till now, is what was given, we have just simplified and we got something like this, that 1 by 2 whole to the power 6. Clear till this much? Okay, so now what we have to do next is the question was to find out the reciprocal of this number, right? So now if you see if I break the powers, now this is called the power of quotient rule. So if you see the formula number 8 actually we are using now, so it should be 1 to the power 6 by 2 to the power 6. I again write in the as a side note that 4 dot means formula, or in just a short form, okay, for 8. So you'll get this formula. This is called the power of quotient rule. So now if you solve this, and you will get 1 to the power 6 will be 1, and this is 2 to the power 6, and 2 to the power 6 is 64. Alright, so it's 1 by 64. So till now we get a very simplified form of this number, that is what is 64, means like 1 by 64. Sorry. Okay. Now the question was to reciprocal this. So the reciprocal of 1 by 64 will be 64. So we got the final answer. So this will be our answer. Alright. This is our answer. I think it's simple. I just want to just put the whole sum in a same screen so that you can take a screenshot if you want, or you can just go just a quick revise all this. Alright. I hope you have done. So moving towards the third sum. So the third sum that I've taken, it's a bit like critical than the previous two sums. So let us do and see that how you have learned, and like if you face any difficulties on this. The sum looks like this. It's given like -3. It's plus 3 whole to the power 4, and then multiplied by 6 to the power -3, and then into 25 whole divided by, it's 10 to the power -2 into 16, and then into 3 to the power -6, and then into 6 whole 1 by 4 whole to the power -2, and then it's a into 1 by 6 whole to the power -1. Is it all right? So now let us what to do here, just to simplify this. Okay, I'm just writing it here. Okay, just we have to simplify. All right. Okay, so let's start with the solution. Let's see. So how to simplify? See, we are going to obviously use the laws of exponents here. So now we are going to look after the same basis. Okay, because if we get the same base, we can write down them as a formula. Like suppose you see here's a 3 to the power -4, and here divided by 3 to the power -6. So if you see that the quotient rule, like the quotient rule for like formula number 5, so we can like subtract the powers. So it's -4 minus of -6, it's for 3. Now see, 6 is not written in the proper way, so we just need to break that 6 and as of 2 into 3. Okay, that is like power of the product rule that we are going to just display this. Okay, and 25 we all know, like it's 5 square. All right, and this is 10 can be written as 2 to the power 5, and there was a 10 to the power -2, so the -2 should be there as it is. 16, as you all know, like 2 to the power 4. I'm not writing 4 square because I've already explained you earlier, and 3 to the power -6 have been already taken, so we don't need to repeat that. All right, because it's already here. So into what we have there, we have like 6 whole 1 by 4. So as you all know, like 6 into 4, it's 24, plus 1 is 25 by 4 whole to the power -2, and this is 1 by 6 whole to the power -1. So as you know, like if the power is minus, we can reciprocal the base. The base is already 1 by 6, so if we reciprocal 1 by 6, we get just 6 by 1 means 6, right? So let us move on to the next step now. So here we have 3 to the power -4 minus of -6, so it will be +6. Actually, now we are going to open this bracket. So the power was -3. So if you closely look at this, the power was, I'm sorry. So let's see. Yeah. So the power was -6 if you closely look at this, and the power was -3. So the -3 power will be distributed on 2 and 3 as well. So means it looks like this: 2 to the power -3 into 3 to the power -3. All right, and that is 5 to the power square. Let it be like that. Now here again the same rule, that the power -2 will be distributed now. So 2 to the power -2 into 5 to the power -2 into 2 to the power 4 as it is. I'm not going to change anything. So it's 25 means it's actually 5 square, and 4 means 2 square, so it's 5 by 2, it's whole square, and there is another power was already there, that was -2 into 6 can be like written as 3 into 2. Let's see, like we can just start the cancellations now. Okay, so now here -4 and +6 we got 3 square, and then if you see there is 2, there is 1 2, there is 2 to the power 4, there is 2 to the power -2. So if I highlight all these 2's, and if I like count all them here, so all the like 2's on the power, on the numerator should be in the positive way, and all the 2's are in the like denominators here, okay, they will be negative because they are in the divided by form. All right, so I'm just going to highlight this plus minus 3. Acha, this your like 2. I need to like check this 1 second. Okay, so what I was saying, yeah. So now acha, another one 2 was here in like lying down there. So let's do one thing. Let me like do the simplification of this. Okay, if I do the simplification of this, then it will be much easier. Then we'll do all together. All right, so it's 3 to the power plus 2. Let it be like this. All will be like that. I'm not going to change anyone. Okay, it's 2 to the power. So it's like 2 to the power minus 2, and then 5 to the power minus 2, and then 2 to the power 4. And if I now like see, there are multiple powers, so it's 2 into minus 2, it's minus 4. So it's basically 5 to the power minus 4 divided by 2 to the power minus 4 into 3 into 2. Let it be exactly like this. Now see, we have 3 different types of prime number here. Okay, one is 3. So let us like mark 3 in circles. So where are 3? Acha, let us mark 2 by like green circles. So 2 are here, here, there one, and there is another one, and let it be like 5 be like with yellow. So 5 1 is here, 1 5 is here, another one is there, right? So now if I start writing them as I've told you earlier, so we are going to write only 1 3, and we are going to write all the powers which are in the numerator first, like this 2. So I'm writing 2. This is minus 3. Sorry. Yeah. So this is minus 3. So this minus 3, and this 3 is only 3. So this is actually 3 to the power plus 1. So it's a plus 1. Now minus all the like subtract all the powers in the like in the denominator. Okay. So now where are 3's in the denominator? Okay, no 3's are there. So nothing to subtract. All right. So it's done already for 3. Okay. So nothing to subtract. Let's go. Okay. Now for 2. What you can see, this minus 3 is there in the numerator, and this 2 is actually plus 1, so it's in the numerator, so it's plus 1. Then minus all the 2's in the like in the green circles. So it's minus 2. This is plus 4. This is a minus 4. So I close the bracket. Again for 5. So this is a 2. This is a 2. This is a minus 4. This is a minus 4. Nothing. No more 5 are there in the numerator. So minus the denominator power, so only one denominator power, that is minus 2, so just a minus 2. Okay, let's now calculate, and the sum is almost done. So it's 2 minus 3 is minus 1, and then plus 1, so all cancelled out. Basically this is 3 to the power 0. And then for 2 it's minus 3 plus 1, it's minus 2, then minus of, we are getting here plus 4 minus 4 cancelled out, so it's basically minus 2, minus of minus 2 will be plus 2, so these 2 also are cancelled out. And now 5, for 5 it's like 2 minus 4 is minus 2, then minus of minus 2 it's plus 2, they are also cancelled out. So basically what I can see, this is like 3 to the power 0 into 2 to the power 0 into 5 to the power 0. So as we can see in formula number 3, that definition of 0 exponent that are all 1, so 1 into 1 into 1, so it's basically a simple 1. What we have used here, that is a formula number here, if you see, this is formula number 3. Alright. So the whole sum I just want to show up you on board. Yeah, mostly the full sum is visible. All right. So let's check it out once, whether you can understand the simplification sum. The sum was a quite bigger one. So this kind of sums you can see like for like 3 marks to 4 marks. Usually have 3 marks. Okay. So hopefully it's clear. Okay. So let us move on to the last sum of today's video, and that is solving equation and finding out the value of x. So the sums look like this: 81 whole to the power minus 2. Division 7 to 9 whole to the power 1 minus x is equal 9 to the power 2x. You all can understand, just we need to find x. That is the question. So well, let us jump to the solution part. Okay, is it clear to all of you? The question is clear. So now we are going to like solve this equation. Okay, so like if we like see this sum, this 81, this is a composite number, and we know that it's 3 to the power 4, so we can simply write 3 to the power 4 whole to the power minus 2. Then division, do anyone knows like 7 to 9 is like power of what time? Like anyone? No one? So this 7 to 9, if you break, you will find out that it's basically simply like 9 to the power cube. Okay, because 9 square is 81. 81 into 9, if you do, you will get 7 to 9. Anyway, so but 9 is a composite number, right? So we cannot write it like this. So we have to write 9 as 3 square and then whole power 3. So it's basically 3 to the power 6. So just remember it is 3 to the power 6. Okay, please remember this bigger numbers, like these are all exponent numbers. Exponents form what? Okay, so anyway, so I'm replacing by 3 to the power 6 and whole to the power 1 minus 6, and that side is 9. It's very simple, it's 3 square, but there is another power, that is 2x. So we are going to use again the same laws that we all have seen and used here. So there are multiple powers, 4 and minus 2, so they're simply multiplied. So I got minus 8, and again there are multiple powers, so I got 3 to the power 6 minus 6x, isn't it? It's a product of algebra. 6 into 1 6 and 6 minus x and 6x, and this side we have 3 to the power 4x, right? Is it all right? Okay, so the next step is very simple. As we can see, the bases are same. You see the base is 3, here also base is 3. So what we can see, the base are same. So we are going to subtract the powers because it's a division. So if we subtract the power, we'll write a single 3. So it's minus 8 minus of 6 minus 6x. Is it all right? That's why we have the same thing, that 3 to the power 4x. Now, what we know that, let me write down the rule. We know that suppose you have a to the power m is equals to a to the power n, means the bases are same. Okay, so the next line we drop the bases, so m equal n, means Mumbai equal Noida. Okay, is it all clear? So if I'm going to use the same thing, because as I saw, like this base 3, this base also 3, so as the bases are same, we are going to just drop the base and make the equation with the powers. If I highlight like this, I think it will be quite easier now for you. So it's minus 8 minus of 6 minus x, and that side is a 4x. Okay, all right, is it all right? Let us continue with this linear equation. In class 6, all of you have learned algebra and you know how to solve this kind of linear equation. Minus 8 minus 6 plus 6x 4x. So let us take all the x in the same side. Like, let us take this 4x here. So it's 6x minus 4x, means separating variables and the constant, and this all are constant, so let us take them there. So if I calculate it here, it's minus 14. So if we go there, it will be plus 14. So if I see this is 2x equals 14, cancel 2 and 14, we are getting here x as 7. So we got the answer. So that's the whole sum. Okay, showing you the full sum on board. So the solution along with the question. So let me know out of this 4 questions. If you have any kinds of doubt, what I'll do today, you see the video, all 4 questions will like comply with the whole chapters, like extracts. Okay, so now just let me know whether there is any doubt, okay, in the comments. And what I'll do tomorrow, I'll give a worksheet on this. So like practice exponents and powers. It's a special worksheet I'll give you, which will be like providing you the most probable questions in the papers. So practice them, and hopefully like after that there won't be any doubt and we are good confident on this particular topic, exponents and power. Thank you for watching this video. Meet you in the next video very soon.